So guys, in the previous video, we studied about the reactions involving the cleavage of OH bond. In that first reaction, we studied about the acidic nature of alcohols and phenols. And we came to know that comparatively your phenols are more acidic than alcohols. And moreover, we also came to know whenever an electron withdrawing groups, I repeat, whenever an electron withdrawing groups are present in the ortho and the para position, the acidic strength of the phenols increases, and if an electron donating groups are present, your acidic strength of the phenol decreases. So basically it was a reaction which we studied under the cleavage of your OH bond. Alva. So in today's video, we are going to study two other reactions which are also coming under the cleavage of OH bond. That means whenever the bond between your oxygen and hydrogen in an alcohol is being broken, what type of a reactions we could have seen in our experiments. Is that clear? So basically the first reaction in today's video we are going to study, which is called as esterification. What it is called as esterification. Of course, I have given you a hint of this in my previous video, that what do you mean by esterification? That is, when an alcohol is treated with carboxylic acid and its derivatives. I repeat, whenever an alcohol is treated with carboxylic acids and its derivatives in the presence of some suitable acids or a base, okay, we will be getting an ester. Yes, so that overall process is called as an esterification. To be more particular, somewhere in your level, we generally define esterification as when an alcohol is treated with a carboxylic acid in the presence of a concentrated sulfuric acid, esters are formed. So that process is called as an esterification. Generally, this process is involved in the identification, or we can say the conformation of your carboxylic acids. So for example, if you have been given with a compound and you have been said to identify whether it is an acid, so what you will do, you will just take that carboxylic acid, you will treat that carboxylic acid with a given alcohol in the presence of concentrated H2SO4. So when the reaction gets complete, we can feel or we can smell a fruity odor, which represents that whatever the product has been formed is an ester. So how can we get an ester? Of course, we know that one of the reactant was an alcohol. There is only a possibility of getting an ester is that the other reactant should be a carboxylic acid. So therefore, this is a reason we can be used this esterification as a test for the identification of carboxylic acid. Okay, but now let us check out some additional information of this esterification. Do remember guys, this esterification process is a reversible process. What it is? It is a reversible process. Why I am saying this? Because whenever we talk about a reversible process, one important law hits our brain. What is that? Yes, it is our Le-Chatelier's principle. Le-Chatelier's principle. Okay, so we are doing with esterification. Why we want here Le-Chatelier's principle will be our question. Of course, many times I have said, whenever we are doing a reaction, it is a protocol, or we can say it is a truth for those scientists or the chemists to increase the yield of the product. I repeat, whenever we do certain reactions in chemistry, always there will be a protocol for us in order to increase the yield of the product. Of course, it was a general reaction, that is of generally if I write in this way, A plus B give rise to C. Of course, there was no other matter. I have to just concentrate about my reactants as A and B. But since when this reactions is involving an equilibrium, I know what? Yes, how much ever the fastness of the reactions is in the forward direction, that much fast itself it will be in the backward direction. Or in simple words, the rate of the forward direction or the forward reaction will be equals to the rate of the backward reaction. So that means what? The concentration of your product as well as your reactants will be equal. So there we have to utilize certain concept so that we can obtain a means in order to increase the yield of the product. That means what? If a reaction is A plus B, which is in equilibrium, to give C plus D, and what I have to do, I have to make this reaction to proceed more in the forward direction and less in the backward direction. So how can I do this? Of course, what I know, A plus B both are the useful reactants, and of course among the product formed C and D, my C is the major. I want this one is in the major product, or its yield should be more. Of course the D will be a byproduct. So what I will try to do, of course since the C I should obtain the maximum yield, what I will do, I will just reduce the concentration of this D, or in simple words, reduce the concentration of the byproduct. So when such thing happens, what happens according to Le-Chatelet principle? Whenever a change is introduced, whenever a change is introduced in an equilibrium system, the system itself will arrange in such a way in order to cancel that change. So according to this, what happens? The introduction of the change is what? I am reducing the concentration of D. So what happens according to Le-Chatelet principle? In order to increase, this change na nullify ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? Concentration of D na increase ಮಾಡಬೇಕು. Increase ಆಗಬೇಕು ಅಂದ್ರೆ ಅರ್ಥ ಏನಾಗಬೇಕು? Of course the rate of the reaction should proceed more in the forward direction. So when it happens, so what happens? Along with the D, D ಬರಂಗೂನು C ಹೇಗೂ ಉಂಟು ಅವಾಗೇನಾಗುತ್ತೆ? C ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So this is what we will be going to observe in our esterification. So what we are going to do over there also we are to increase the yield of the ester. So whatever the product will be formed in the cases, we are going to remove those products. So when I do such things, what happens? The rate of the forward direction will be more and the yield of the ester obtained will be also more. Don't get confused. When we will see the reaction, you will be getting to know better things. Okay. So coming now, first of all, when I am talking here about esterification, do remember I have mentioned in my earlier definition, I am going to use acid and its derivatives. Acids and its derivatives. What does it mean? So basically we are going to talk about the esterification with respect to the three important compounds. One is the carboxylic acid. Another is your acid chloride, and one more, which is your acid anhydride. That means, of course, in all these three cases, we are going to treat our alcohols, and in all these three cases, we are going to get esters itself. But of course, the byproducts will be different, that we are going to see in the reactions. Okay, so first let us start with our carboxylic acid. What does it say? So whenever an alcohol is treated with a carboxylic acid, remember, in the presence of concentrated sulfuric acid. This is very much important, and do remember this reaction is in equilibrium. Okay, so whenever alcohol is treated with a carboxylic acid in the presence of your concentrated sulfuric acid, we will be getting an ester. But along with that ester, I am getting a byproduct of water. So why did I explain this concept earlier? Because so when we are doing this reaction, that is treating your alcohol with a carboxylic acid, In this process, again and again we are removing the water. Why we are doing so? You can just see the length of the arrow marks. Of course they are same. So when I am removing the water, what happens? The forward direction will be more and the backward reaction will be less. That means what? I am going to increase the yield of the ester by removing the water which has been formed. So in order to understand this, we have to understand about Le-Chatelier principle. Since the reaction was involved in an equilibrium, yes, that means what? Rate of the forward reaction was equal to the rate of the backward reaction. So when such a reaction was seen, when I am in that reaction, I am inducing a change. What is that change? I am removing the water. So what happens? I have induced a change. So according to Le-Chatelier principle, what it will try to do? By some way, it will try to increase the concentration of the water. That is only possible if the reaction proceeds in the forward direction. Again and again, if I am going to remove the water, what happens? More and more your forward reaction will be favored, and in simple terms, our yield of the ester obtained will be more. So this was what we have been observed when our alcohol is treated with a carboxylic acid. Why I am saying this? In certain scenarios, they can ask you. So during an esterification, why there is a necessary to remove the water formed in the reaction? So in that case, you have to understand, in order to answer that question, you have to understand the main Le-Chatelier principle, and you have to know that this esterification process is in equilibrium. Is that clear? Okay. So let us give an example for this. For example, if I am going to take as an alcohol, ethanol na tagonala, C2H5OH. So this is treated with our acetic acid. Let me take my acetic acid is in this way. COOCH3 alva. So this is my ethanol, this is my acetic acid. Okay. So what happens when this is treated with that of your H plus? What I'm going to get? Yes. So you are going to get CH3, COO, C2H5 plus water. Are you able to see? So once again we have got an ester over here. Just we are taken a R ಗೆ ನಾನು ಏನು ಮಾಡಿದ್ದೀನಿ C2H5, ಇನ್ನೊಂದು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ಗೆ ನಾನು CH3 add ಮಾಡಿದ್ದೀನಿ. Why I have written in this way will be a certain confusing, because remember this is a reaction which is coming under the cleavage of your OH bond. Just I want to show that. Of course, when I am using the water, you have come to know. When I am using the acid, moreover you have come to know why I have used, because it is facilitating to remove that of your water, acting as a dehydrating agent. Alva. Consider H2SO4 is a good dehydrating agent. So how the bond is breaking, do remember. As I have said, this is coming under the concept of cleavage of OH bond. See, the H from the alcohol and the OH from the acid is removed. I repeat, the H from the alcohol and the OH from the acid is removed. Of course, H plus and OH minus forms the water. Since the cleavage is involved here, you can see the cleavage is between O and the H. For that reason, the esterification is coming under the cleavage of OH bond reactions. Is that clear? Okay. Now since we have seen the reaction of alcohol with a carboxylic acid, now let us see about its derivative. Alva. That is acid chloride. That means what? When our alcohol, so now when we treat this alcohol with an acid chloride, you just pay attention how I am writing my acid chloride. The general formula of acid chloride is RCOCl. Can you see? The general representation of an acid chloride is what? RCOCl. Okay. So basically you just remember, whenever this reaction is being carried out, it is taking place in the presence of pyridine. What? The reaction of your alcohol with an acid chloride is being carried out in the presence of pyridine. I will say why it is. But do remember, pyridine is a base. Pyridine is a base. So of course, when this reaction is proceeding, the product will be obtained is an ester, RCOOR. Along with that one, what you are going to get is a HCl. I think many of you have come to know that why I have used the pyridine over here. Once again, the reaction is in equilibrium. So I have to make sure that my reaction should more be concentrated in the forward direction. So what I should do, as here I have removed the water. It was my, task to remove the water. But here what I am doing, I don't want to indulge in my work. Okay, so what I will do, within the system itself, the byproduct has to get reduced, or its concentration has to get reduced. So what I have done, of course, the formed byproduct is an acid. So in order to neutralize this acid, what I require is a base. For that reason, what I choose, pyridine I have choose as a base. So what happens, as soon as the HCl will be formed, the pyridine being a base try to neutralize this HCl. So once the concentration of the HCl decreases, what happens according to Le-Chatelier principle, forward direction will be favored. Of course, the yield of your ester will be more, or you will be obtaining a higher yield of your ester. For that is the reason pyridine is used in case of your acid chloride. So why it is used? Only because of the formed byproduct is your acid. Is that clear? So whenever an alcohol is treated with an acid chloride, of course an ester is formed. Along with an ester, HCl is formed. In order to neutralize this HCl, pyridine must and should be used. Since pyridine being a base, it will neutralize your HCl, favoring the forward reaction of your ester formation. Is that clear? Once again, let me choose here how we are saying that it is a cleavage of your OH bond. Of course, you can only say. So now this involves what? R, O and a H. So I can write this one as Cl, C double bond O and an R. So what happens? Of course, the cleavage of your OH bond takes place. Here now HCl is moving out. You can just see. Then what is the remaining part? ROCOR. Alva. So I can write it as an RCOOR plus HCl. This is what I have written over here. Is that clear? So remember, to write acid chloride, you have to remember its formula. What is the formula? General representation is RCOCl. For example, if I choose my phenol, okay, my phenol is in this way, OH. So when I treat my phenol with, let me take CH3COCl. Okay, CH3COCl. So this one I am to have to use in the presence of what? Pyridine. So what happens? What is the product you will be getting? Of course, 1R is my phenol. So alcohol in a O will be retained. Okay. Now what should come? Once again, you have to come with COCH3. So OCOCH3. Are you able to see? Why I have given this example? Because it will be clearly showing where the cleavage is going. In case if it was with OH and here Cl, so C should come and attach to the benzene ring. But what has happened? Since the cleavage is O and the H matra hogta undu artha enu benzene ge O has been intact. O benzene ge attach age irutte. So yene further attachment idru kuda enagbeku adu O ge attach agbeke vinaha benzene ina carbon galla. So this is what you will be obtaining. Is that clear? OCOCH3 plus HCl. So by this way we are making sure that whenever an alcohol is treated with an acid chloride, you will be getting an ester along with an HCl. In order to neutralize this HCl, we will be using pyridine as a base. Okay. So two reactions we have seen, that is with respect to the carboxylic acid and one of its derivative, that is our acid chloride. So now one more is left, which is called as what? Acid anhydride. So before going to the reaction, let me show you how to write this acid anhydride, the general representation of our acid anhydride. So basically, it is written as RCO twice O. So we write acid anhydrides is in this way. For example, I have been asked to write acetic anhydride. What? Acetic anhydride. So how can I write this? CH3CO. Can you see? Overall, this is only twice and only one oxygen at the outer part. How the general structure is, let me show you. CH3CO, you can just see, which has been linked with the oxygen. Once again, C double bond O, CH3. Can you see? So CH3CO is twice alva. That is what we have written here. One CH3CO, another CH3CO. So it is twice. Only one oxygen which is written outside. So this is a representation of our acid anhydrides. Acetic anhydride, just you have to write CH3CO twice O. So in place of R, you have to substitute CH3 when you're writing acetic anhydride. General representation of acid anhydride. So this is called as what? Acid anhydride. One of the derivative of carboxylic acid. So what we have done? RCO twice O is called as what? Acid anhydrides. So what happens? So when alcohol is treated with acid anhydrides, that is RCO twice O, remember once again, in the presence of sulfuric acid, small amount of concentrated sulfuric acid, we will be getting our esters, RCOO, R dash. But here the important byproduct is also once again a carboxylic acid. So what we have done, whenever an alcohol is treated with an acid anhydride, in the presence of a small amount of a concentrated sulfuric acid, we will be obtaining our ester. Is that clear? Let's give an example for this. Let me choose here now R as a CH3OH, and here I will be choosing as CH3CO twice O. That is methanol. When it is treated with an acetic anhydride, what happens? Let us see. So we'll be getting what? Yes, CH3COO CH3. Alva. So totally it is called as what? Propanoate. Alva. 8 anad baradi adukke whenever it is an ester idre functional group name is 8. 3 carbon atoms, single bond, ane. So what is the functional group name? 8. So propanoate. Okay. Along with that one, what you are going to get is our CH3COOH. So why I have written it? It will be more if I take it as an R dash. Okay. So what happens? So this R and this R, of course, one R has, since it is 2 times alpha. So this R itself forming with an ester, and also the same R will be forming an acid. Why I am showing it in this way? Of course, whatever I have used was both here CH3 and a CH3. So when it comes in this way now, CH3OH plus C2H5CO twice O. So identify your A and B anta bardaga. There should be not a confusion. Remember, first one barutte CH3COO C2H5. Alva 1 R inundar. Hinundar idu ulkondirutte. So don't write this CH3. Instead, what you have to write? Yes, C2H5COOH. Certain times we make a mistake. What is that? We will be writing as CH3COOH. It is not possible. Why? Because it is only one mole which is present. Only one part which is present. But here we can just see that whatever the alkyl group is present here, 2 times they are present. So it has to only come where to form your respective carboxylic acid, not our methanoic acid. Okay. What it will be forming is a propanoic acid, not the ethanoic acid. Is that clear? Okay. So in today's video, till now we have seen an important reaction which is called as what? Esterification. And do remember, whenever you have been asked to define esterification, you just make use of alcohol and carboxylic acid because it is the most commonly used definition. Whenever an alcohol is treated with a carboxylic acid in the presence of concentrated sulfuric acid, that is very much important. In the presence of concentrated sulfuric acid, esters are formed. So that process or that reaction is called as what? Esterification. So there we have seen this esterification is a reversible process. So it has to follow a Le Chatelier principle in order to increase the yield of our ester. and we saw the carboxylic acid and its derivatives. Whenever an alcohol is reacted with the carboxylic acid and its derivatives, the most common important product we are obtaining is a ester itself. But along with the esters, we are getting some byproducts. In order to increase the yield, we have to remove those byproducts. So when it was treated with an acid, of course the byproduct form was a water. We removed it externally. When it was with respect to the acid chloride, the form byproduct was an HCl. So it was neutralized by using pyridine as a base. Then we saw with respect to the acetic anhydride how to write it. That is CH3CO twice O, which is called as an acetic anhydride. General representation of acid anhydride is what? RCO twice O. Okay. So how to write? We have look out for here. Remember, whenever we are carrying out this reaction, that is with acetic anhydride or acid anhydride, a small amount of our sulfuric acid is concentrated sulfuric acid is must and should. And do remember, in esterification we have to use concentrated sulfuric acid itself. And it is one of the major important reaction for the identification of the functional group of your carboxylic acid. So whenever carboxylic acid is reacting with an alcohol, you will be getting an ester. And how we will be coming to know it? By the fruity odor. By the fruity odor of our esters. So if you get a fruity odor, which indicates that whatever the compound you have been given, this is the carboxylic acid. Is that clear? So next important reaction we are going to study, which is called as what? Acetylation. What it is called as? Acetylation. So guys, now we are going to see another important reaction which is called as acetylation. Acetylation. So first let us understand what do you mean by this acetylation. Remember, whenever the alcohol or phenol is introduced with acetyl group, that is CH3CO group. Okay, acetyl group andre CH3CO. So that process is called as acetylation. One of my most, we can say, interesting reaction when I was in PUC. Because till now what we have heard, chemistry is very much important in the manufacture of drugs. Alva. Many cases I have only said it is the major advantage of the chemistry is a wide variety of the drugs can be seen whenever we talk about chemistry. Because drugs, which in turn is depend upon chemicals means chemistry. But in this reaction we are mainly going to see that how in pharmaceutical companies they are going to prepare certain drugs. Since now we are in the pandemic of coronavirus, of course all are very much eager to know that how a covaxin is determined. What type of a medicine is it? How they will be introduced. But in this scenario, we are not going to see about covaxin. Instead, we are going to see one of the basic drug that is called as an aspirin. That is called as what? Aspirin. How this aspirin is being manufactured in our companies or in our pharmaceutical companies. What are the reactions they are carried out? So those who don't know what do you mean by aspirin, first let us know what are the important role played by this drug called as aspirin. Remember, this aspirin is a drug can be used as an analgesic. Analgesic. What do you mean by, sir, analgesic? If somebody is asking me. Remember, let me split this word. And which means without. Without. Analgesic means pain. Analgesic means pain. So when we combine this word, what does it mean? Without pain. That is, it is mainly this aspirin can be having the property to control the pain. If there is a severe accident or something, will be administered with this drug so that there will be some pain relieving in our body. So it has one role as an analgesic. That means what? That is controlling pain. Control pain. Not only that, it also has a capacity of anti-inflammatory. Anti-inflammatory. What does you mean by this? Anti-inflammatory means to reduce inflammation. Reduce inflammation. What do you mean by this inflammation? That is swelling. Whenever your body has been administered with some wounds, there will be rapid swelling, which will be very much painful. So in order to reduce that swelling also, this aspirin is used, and as a medical term, we say it as what? Anti-inflammatory. That is to reduce the swelling. So we have seen what aspirin is acting as an analgesic, which means that controls pain. It also acts as an anti-inflammatory. That means what? It reduces the swelling. Not only that, it also acts as an antipyretic. Antipyretic drug. What does this mean? That means it can be also used to reduce the fever. Are you able to see what are the important capacities your aspirin is having? So today we have got a wide opportunity to know that how this aspirin is prepared in our pharmaceutical companies. Okay, do remember, one hint is with us that we are studying about the manufacturing of aspirin under the concept of acetylation. There we have got a hint. What is that? Of course, we are going to use the alcohol, and in our aspirin there will be an acetyl group attached. So let us see how this takes place. Remember, basically, when OH, or you can take it as a COOH, yes, and over here as an OH. So here, so this is our main reactant, which can be given as a IUPAC name as what? 2-hydroxy benzoic acid. 2-hydroxy benzoic acid. The common name is very much important of this reactant, which is called as salicylic acid. So this is 1, this is 2 alpha. So 2-hydroxy benzoic acid is the IUPAC name, whereas the common name is also important because sometimes they can give you the common name also. So what is called as salicylic acid. Remember, very much important. So when the salicylic acid is treated with acetic anhydride, what I am saying? When the salicylic acid is treated with acetic anhydride, can you please help me how to write acetic anhydride? Of course, acetic anhydride is an acid anhydride, and we know that acid anhydride, how we are going to write? RCO twice O. Yes or no? So what does it mean? Acetic anhydride means R should be CH3. So CH3 CO twice O. Are you able to see? So this is taking place in the presence of small concentrations of sulfuric acid, H+. So what you are going to get? Yes. So of course it is coming under the concept of acetylation. So our acid group will be over here itself. COOH is there itself. No matters. Now what you are going to do? COOH irado agirutte. Acetylation again agbiga OH kadege alva. This is the alcoholic group. Alcohol group atra again barbeku acetyl group should come and attach. And we know that acetyl group is what? COCH3. Since it is coming under the cleavage of OH bond, what will be there? O will be there itself. It is replacing your H by acetyl group. That is COCH3. COCH3 and a byproduct as CH3 COOH. So this is called as acetyl salicylic acid. Acetyl salicylic acid, or also as aspirin. And the byproduct obtained is over here as acetic acid. Is that clear? So one of the most important question which can be asked in your PU board exam, what is that? How can you convert salicylic acid to aspirin, they can ask you, or give a brief note on the reaction involved in the production of aspirin. So one of the most important reaction, remember, what you have to use from salicylic acid when it is treated with an acetic anhydride in the presence of a concentrated H2SO4, we will be getting an acetyl salicylic acid, or which is also called as an aspirin. Okay, aspirin is a drug name. Okay, but the common name what you can use for the structure is the acetyl salicylic acid. Is that clear? So here let us give some additional information. What is the additional information? Remember, so when your phenol, when the phenol is treated with, as we have seen earlier, CH3COCl. So what you are going to get over here? Yes, an acetyl group is coming and attacking over here, alva, CH3. So here also this can be also an example of your acetylation itself. Formation of your ester itself. Why I am saying this, I will be just saying in a couple of time. Now once again, if I am going to use now here my alkophenol with that of your acetic anhydride, how can I write it? Yes, CH3CO, O, C double bond O, CH3. So what you'll be going to get? Yes, you're going to get as O, C double bond O, CH3. In both the cases, the product are same, but the reactants are different. One case we have used an acid chloride, in another case we have used an acid anhydride. Is that clear? But what I want to just suggest you over here is, remember guys, so in your competitive exams they will not ask you directly. Okay, why I'm saying this? Because first and the foremost thing, whatever the important reactant we are choosing here, salicylic acid, let us first know how they are preparing it. Remember, when your benzene, when your benzene is attached with an alcoholic group, what it is called as phenol. Okay, when this phenol is treated in the presence of NaOH, of course you are going to get what? Sodium phenoxide, Na. So when this is treated with your carbon dioxide in the presence of an acidic medium, then you are getting your salicylic acid. Can you see? So by this way, here when you're treating, here H plus has removed this Na, and whatever your CO group was there, that has come and attached as a carboxylic acidic group. So by this way, we are preparing our salicylic acid. Is that clear? Why I have said this? Because certain cases in your competitive exams, let me show you what they will do. Okay, they will be giving you the benzene. Now they will be giving you the reactant. What are the reactants? That is NaOH plus HCl. They will say you to identify A. Then afterwards they will be giving you once again NaOH. They will be saying you identify B. Then they will be giving you CO2 in the presence of H plus. Identify C. And then the final thing, then this is treated with CH3CO twice, so identify D. They will be giving you a sequence of 4 options in which they can give different option, or they can just give these same answers, whether it's the right answers, but they will be just mixing up A ಗೊಂದು B ಗೊಂದು C ಗೊಂದು D ಗೊಂದು ಕರೆಕ್ಟ್ ಸೀಕ್ವೆನ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರಲ್ಲ, ಯಾವುದೋ ಒಂದು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಸೀಕ್ವೆನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಆ ಒಂದು ಸೀಕ್ವೆನ್ಸ್ ಅನ್ನು ಗೊತ್ತು ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ, ಯು ಹ್ಯಾವ್ ಟು ಫಸ್ಟ್ ಸಿ ವಾಟ್ ಆರ್ ದಿ ಪ್ರಾಡಕ್ಟ್ಸ್ they will be forming here respectively. Of course, we see whenever we have to prepare our phenol from our benzene, what we did when benzene is treated in the presence of NaOH, and on acidification, what is the product we are going for? A. Yes, it is our phenol. It is our phenol. Then once again this phenol is treated in the presence of NaOH, what happens? Of course, you are going to get what? Sodium phenoxide. Sodium phenoxide. So this sodium phenoxide, when it is treated with the carbon dioxide in the presence of H plus, yes, you are going to get our salicylic acid. See the position of OH and COH, very much important. ONA group elli irutto alli H plus ಮಾಡಿದಾಗ OH group ಬರಬೇಕು ಅಲ್ವಾ? ಅದು ನಾವು ನೋಡಿದೀವಿ when we were preparing phenols. Then when it is treated with an acetic anhydride, you are going to get our respective acetyl salicylic acid. Acetyl salicylic acid. So this way you have to study the organic reactions if you want to crack your competitive exams. You have to just remember, whenever you're talking about organic reactions, you'd have your mindset in such a way that you have to relate the reactions. Haloalkanes, haloarenes in the alcohols, phenols, ethers ಗೆ ಯಾವ ತರ ಲಿಂಕ್ ಉಂಟು, ಅದೇ ರೀತಿ ಆಲ್ಕೋಹಾಲ್ ಫಿನಾಲ್ಸ್ ಈಥರ್ಸ್ ಇಂದ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಮತ್ತೆ ಎಸ್ಟರಿಗೆ ಯಾವ ತರ ಲಿಂಕ್ ಉಂಟು, ಅದೇ ರೀತಿ ಅದು ಅಮೈನ್ಸ್ ಗೆ ಯಾವ ತರ ಲಿಂಕ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನೀವೇ ಒಂದು book na maintain ಮಾಡಬೇಕು, which is giving you the sequence of those reactions. So this is the way in your competitive exams they are going to ask you. Of course, in PU board exam, as I have said, they will be giving you directly the question. You have to just write it. That is how can you prepare aspirin from salicylic acid. They can ask you, just a direct question. But do remember, whenever you're writing it, such reaction, first you have to focus that how you have to write in a theory part. ಯಾವತ್ತೇ ನಾನು ಒಂದು ರಿಯಾಕ್ಷನ್ ಕೇಳಿದ್ದಾರೆ ಅಂದಾಗ first you have to write the theory part and then you have to write its respective reactions. Is that clear? So in today's video we have seen the two important types of the reactions. One is called as an esterification. There we saw how does by utilizing your carboxylic acid and its respective derivatives, when it's treated with an alcohol, we are getting our respective esters. And do remember, our esterification is an equilibrium process. So in order to increase the yield, what we have done, I have just mentioned it, go through it once again. Then coming with respect to the acetylation, we came to know that whenever an alcoholic groups or the phenol groups have been replaced or been added, introduced with an acetyl group, you will be getting that process is called as an acetylation. There, one of the most important and worthy reaction we have seen, that how can we manufacture aspirin? What is the general protocol followed in your pharmaceutical companies in order to manufacture aspirin? So aspirin means what? It's one of the most important drug which can be used as an analgesic. Very much important. These medical terms are also very much important. Analgesic, which reduces the pain. Anti-inflammatory, which reduces the swelling. Then coming with respect to what? Antipyretic, which reduces the fever. So we saw that how can we prepare such aspirin from salicylic acid. And do remember, once again I am repeating, whenever we are writing the acetyl salicylic acid, the overall aspirin should be written in this way itself. OHOCOCH3. Very much important. Why? Because this is the reaction which is coming under the category of cleavage of OH bond. Some fellows you write in this way. How is that? OHCOOCH3. This is wrong. Why it is wrong? Because whatever the carbon of your benzene is there, it is not linked to the ester's carbon. Instead, it is linked to our oxygen. So the linkage is very much important. Illinda bond ಆಗ್ತಾ ಉಂಟು ಅಂತನೂ ಕೇಳ ಸಾಧ್ಯತೆಗಳು ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. So you have to pay much more attention whenever you're writing this structures. So whenever we are writing an aspirin structure, it has to be written in this way itself. Why? Because whatever the reaction is involved is the involving of cleavage of OH bond. Okay, H is moving, O has been there itself. To that O, our acetyl group is coming and sitting. Is that clear? So in our next video, we are going to see certain reactions which involves the cleavage of our COH bond. ಅಲ್ವಾ? ಇಲ್ಲಿವರೆಗೆ ನಾವೇನ್ ನೋಡಿದ್ವಿ, OH ಬಾಂಡ್ ಬ್ರೇಕ್ ಆದಾಗ ಯಾವ ತರ ರಿಯಾಕ್ಷನ್ಸ್ ಆಗುತ್ತೆ ಅಂತ ನೋಡಿದ್ವಿ. ಇನ್ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ದ ಕ್ಲೀವೇಜ್ ಆಫ್ ಅವರ್ COH ಬಾಂಡ್. ಓಕೆ, ಎಸ್.